students, our today's topic is the function notation, the input, output, and the function machine. Now that we know that not every mapping is a function, so how to express the functions? What will be the notation? How to write the input on the output? And what is a function machine? We'll be knowing about all these in our today's session. A function can be written as if. If is the name of the function. We'll be coming to this F part in detail later on today in this very session. Followed by colon and then x, then this arrow and 2x plus 1. You can have some other expression also over here. You can have in place of x, you can have some other letter in place of f also, you can have some other letter. We'll be knowing about the meaning of these things very soon. But this can also be written as f of x equal to 2x plus 1 or as y equals 2x plus 1. And we express a function in either this form, f of x equal to some expression or y equal to some expression. We hardly ever use this one, but this is also one of the notations, and you may have this type of a notation for a function in some question, and if you don't know how to read this, you'll not be able to answer the question. As simple as that. Okay, so you have to remember this form also, but when you are free to write, you're free to use any form, so you can use either of these. Of course, you can use this as well. Okay, but when you are using or when you are seeing y equals to x plus 1 or y equals some algebraic expression, you have to be careful about this, that not every equation of the form y equals some algebraic expression is a function, because we have seen every mapping process can be expressed in the form of y equals some algebraic expression, and not every mapping is a function. So whenever you see y equals something, do not just assume that it is a function expression. But when it is given that f of x is equal to some algebraic expression, then definitely it is a function expression. Okay. Now, the f of x or y is called the function value or image of x. If you don't know these terms, if you have a 1-mark question that give the image of x for a function, you won't be able to answer. This is especially for the AAHL students. So you have to know what is meant by the image of x in a function. F of x is the function value or y is the function value, or f of x or y can be said to be the image of x. Now coming to the function machine part. The function f, this f, okay? The function f can be thought of as the name of a machine. Nowadays, we are just surrounded by machines. Laptop is a machine, our mobiles, they are also machines. The fan, the refrigerator, everything is a machine. Of course, human beings are not machines, but these are machines, and all of them have unique names. Because we have to, in order to refer to them, we need their names. Similarly, for a function machine, for any mathematical machine, we also need some name. Otherwise, how to refer to them? So, in our today's session, we are taking up a function machine whose name is f. You can give some other name to the function machine, doesn't matter. Even a single person has so many names. So, if I call the function machine as f and you call the same function machine as g, no problem. But you have to remember, and I have to remember as well, that they refer to the same machine. Okay? And what does this machine do? It can take certain values as inputs, and the set of all input values that it can take form the domain set. And after performing some operations on the input, outputs corresponding values. And the set of all output values form the range set. Okay? Now let us see the structure of the function machine. This is simple, a rectangular box. You can have a square box. You can have an elliptical box. The shape doesn't matter, of course. And this is the function machine named f. And what is the operation that it is performing? It is doubling the input and it is adding 1 to the product. Doubles the input and adds 1 to it. And this is the input and this is the output from the function machine. And you can have a number as the input, a variable as the input, an expression, algebraic expression as the input to the function machine. Not only algebraic expression, you can have a numerical expression as well as the input to the function machine. Okay, I'm taking x as the input. Now the function machine has got this variable x. What it will do? It will double the input. Double means multiplying by 2. So it will be multiplying this x by 2 and we get 2x. And it will be adding 1 to it. So it is 2x plus 1, which will be the output from the function machine. See, this is the function value. So f of x is the function value or image of x. This means that there is a function machine named f. And from this function machine named f, first of all, we are inputting x to that function machine. And from this function machine f, we are getting the corresponding output as 2x plus 1. This is the meaning of this statement. Okay? When x is inputted to this function machine f, we get the corresponding output as 2x plus 1. Now coming to few questions. If f of x equal to 2x plus 1, then what will be f of 0, f of 3, f of negative 1 and f of 2p? See, f of 0, whatever is within the parenthesis after the function name, that represents the input to the function machine. When this is x, x is the input. When this is 0, 0 is the input. As I have said, the input can be a variable, it can be a number, it can be an expression. Okay? So they have given, and the function machine is the same. It is f. It is this one. And they have also said what is the input and what is the output from the function machine. So they did not give the operation in writing in a statement form, but they have given in mathematical form that when x is inputted to this function machine f, 2x plus 1 is the output from the function machine f. So when the input is 0, the output should be, it will be doubling the input. 2 times 0 is 0 and it will be adding 1 to it. 0 plus 1 is 1. Or else what you can do, if this is not given, this statement form of operation is not given, you don't need it actually. You have the output expression. Just substitute the input in place of x, because when x is the input, this is the output. So when 0 is the input, what will be the output? So just in place of x, you substitute 0. 2 times 0 plus 1 is 1. Next is f of 3. That means the input is 3. Output will be 2 times x means 2 times 3 plus 1, which is 7. Third one, subpart C, input is f of negative 1, so input is negative 1. Output will be 2 times negative 1 plus 1. 2 times negative 1 is negative 2 plus 1 is negative 1. And finally, we have an expression 2p as the input. Output will be 2 times 2p. In place of x, we are substituting 2p plus 1. 2 times 2p is 4p plus 1 is the corresponding output expression. Okay? So students, this brings us to the end of this session. I'm Nilanjana Sanyal and this is my channel Ines Online Math Classes. Thank you for watching this video till the end. Please like and share this video if you find it useful. Please subscribe to my YouTube channel if you have not subscribed till now. It will be motivating me to make more math videos for you. Please let me know if you have any question in the comment area. Bye.